Yes, sir.
Yes, sir.
Okay, I'm going to draw the graph and cross check it. Now the first is isobaric process. Fawaz, am I audible to you?
Yes, sir.
Okay, in isobaric process, I can say that pressure is constant. That means dp equals to 0 and delta p is also equals to 0. The graph between v and t, the graph between, I'm sharing it again. The graph between volume versus temperature. You can see volume directly proportional to temperature at constant pressure and number of moles according to Charles law. This relation was given by Charles. Here pressure is constant and we know the graph will be like this. You can see pressure is constant, here P is constant, and from the graph you can see this is the direction. The directions says that the volume is continuously increasing. That means it is a graph of isobaric expansion, right? Everyone.
Yes, sir.
Again, another graph in of same, like v versus t, it will be like this and the direction will be reversed. This is the graph of isobaric compression, Krishna, right?
Yes, sir.
Okay, come to this point, pressure versus volume. We need to plot a graph for isobaric process and we know that pressure is constant, so the graph will be parallel to x-axis like this, right?
Yes, sir.
If I will give the direction this, it will be isobaric expansion, isobaric expansion, right? And another graph for the same, but the direction will be reversed, p versus v. Wait, it is p versus v. The graph is reversed, so it is isobaric compression, right? Because volume is decreasing. For us,
Yes, sir.
and p versus t, pressure is constant, so it will be like this, and I am giving the direction in the right, and again graph between p versus t, and I am giving the direction in left. Now you can see pressure is constant, and here what you can say about expansion and compression, Ifra, Krishna, and Fawaz? Is it expansion or compression? And what about this, expansion or compression?
So the first
Sir,
one is
first one
expansion, sir,
expansion.
because temperature is increasing.
Temperature
So
increasing, volume is increasing, so it is isobaric expansion. Isobaric expansion, and temperature is decreasing, volume is decreasing, that means it is isobaric compression, right?
yes, sir.
Yes, sir.
Very good. Can I change the slide?
Yes, sir.
Yes.
Okay, so we will move to isochoric process. So the next process is isochoric process. And we will see what is isochoric process. Isochoric process, the process in which volume is constant throughout the process, is called isochoric process. So we know that if volume is constant, that means dV equals to constant, and in the same way delta V is also equals to constant. Is it clear? It's so easy. Now
Yes.
we are going to plot graph for isochoric process. First, PT, you have to draw two graph of P versus T. I already told in the previous lecture. The just you will do the reverse. The direction will be reverse. P versus V. Now we have three graph of our isochoric process. You plot this, then we will come to third graph. Done.
Yes, sir.
Very good. Now you will see here V is constant, and we know a relation of P versus T, that is Galo-Sachs law, in which it is Galo-Sachs law. What it says is pressure directly proportional to temperature at constant volume and number of moles. And here what we need, constant volume. So volume is constant, and we know the graph between P and T will be like this, a straight line. Now we will have two graphs on this on the basis of direction P versus T, and in which I am giving the direction upward, and here I am giving the direction downward. Let me know which is expansion and which is compression. Now see here, temperature is rising. Temperature is rising with pressure, but volume is constant here. Here what? Here volume is constant, so there will be no expansion as well as no compression, right? Krishna?
Yes, sir.
Yes, sir.
If volume is Fawaz, is there
Yes,
any,
sir.
is there any other students? Let me check. If okay. Students are here. Okay. What I am trying to say is that here you can see volume is constant. That means volume will neither increase nor decrease. That means neither expansion nor compression. So what will happen whenever this situation will come, we will deal with cooling and heating. So this is isochoric process, we know that, because volume is constant. Then this is isochoric heating, because temperature is increasing, and whenever volume is constant, then we will talk about heating and cooling. And here you can see it is isochoric process, and temperature is decreasing, so isochoric cooling. Is that clear?
Yes,
Yes,
sir.
sir.
Now, what about this graph? You can see volume is constant. That means the graph will be like this. And I'm giving you like the direction in the upward. And again, PV graph, the direction will be downward. You can see volume is constant. Volume is constant. You first
Yes,
decide which process is this. Then we will come to know it is isochoric. It is isochoric. And you can see pressure is increasing. If pressure will increase, then temperature will also increase.
Increase.
That means isochoric heating, and it is isochoric cooling. If there is any doubt regarding this, ask me. Everyone done with this?
Yes, sir.
Krishna?
Yes, sir. Just 1 second, sir.
Okay, take your time, no problem.
Done, sir.
Fawaz done.
Done, sir.
Okay, come to the next graph. We have V versus T. Now plot it and let me know. There will be two graph of V versus T depending upon the direction.
Done, sir.
Okay, Krishna?
Just a second, sir. 1 second. Done, sir.
What about you, Fawaz?
Done, sir.
Done. Isochoric process, the volume will be constant, so the graph will be like this. I'm giving you direction this, and here the direction this. You can see volume is constant. So in terms of cooling and heating, you can see it is isochoric, and temperature is rising. So it is heating, isochoric
Heating.
heating, because temperature is rising. And here you can see temperature is decreasing in this direction, and in this direction here temperature is increasing. So it will be isochoric cooling. Everyone done with this?
Yes, sir.
Yes, sir.
Very good. So we have isochoric, isobaric, isothermal process. Now we will come to adiabatic process. Adiabatic process. I already told you in previous the first lecture, adiabatic wall. Do you remember it?
Yes, sir.
So here comes adiabatic process. Adiabatic process. What is adiabatic process? First, I'm going to write with me, please. The process in which there is no exchange of heat between system and surrounding is called adiabatic process. There is no exchange of heat between system and surrounding is called adiabatic process. Basically, adiabatic process is that in which Q equals to Q, that means heat. Q means heat. Q equals to 0. So you can also write dq is also equals to 0. If there will be no exchange of heat energy between system and surrounding, that means the heat will be 0. Is that correct, Krishna, Ifra?
Yes, sir.
Yes, sir.
System there, if we have a system, just suppose we have a system in which the wall is the boundary is made up of adiabatic wall. Adiabatic wall, remember the term adiabatic wall. And if you want to heat it, if you want to heat it with rising temperature, will there be any heat energy in the container? Yes or no?
No, sir.
Krishna,
No,
Fawaz?
sir.
Because this wall or this boundary won't allow heat to pass through that. That means Q equals to 0 or not,
Yes,
Fawaz?
sir.
Yes, sir, it will.
So that means the process in which there is no flow of heat between system and surrounding, that means Q equals to 0, is adiabatic process. So write it.
None, sir.
Done, sir.
Done. Very good. Now come to the next process, which is cyclic process. Remember, cyclic process is a process in which the process starts with the same point and ends with on the same point. Is that clear? Just see, I'm going to write the definition right with me. The process in which it's too easy, in which initial and final state are same. The process in which initial and final state are same, but proceeds with series of steps is called cyclic process. I already told you that the initial and final state are same. That process is known as cyclic process. Let me know if you are done with this, then I will explain it.
Done, sir.
Everyone done?
Yes, sir.
Very good. Now you can see here I am going to draw a graph between P versus V. The graph is like this: A, B, C. The direction is important. So you can see first I am starting with point A and go to point B. Again starting with B and go to point C, and again C to A. Basically it starts with series of steps, different steps, many steps, and on the same point where it started. So I wrote here the process in which initial and final state are same. This is important. The process in which initial and final state are same and proceed with series of steps is called cyclic process. Is that clear?
Yes, sir.
Yes, sir.
If I will ask which process is AC, this graph is given, and if I am asking which process is AC, can you answer it? AC, just see AC or CA, which process is not AC. This will represent it is going from A to C. So I am asking it, what is the process shown by graph CA? You can see CA, constant volume. That means constant volume, na Krishna, Fawad,
Yes, sir.
Afra? That means
Yes, sir. Isochoric.
isochoric. If I will ask what about BC, that is isobaric. So we will do a lot of question or graph in a single question in which we will cover all the topics. Okay, so this is I just asked for confirmation. Just write this and let me know.
Done, sir.
Done, everyone?
Done, sir.
Fawaz?
Done, sir.
Okay, I won't be able to see the chat, so try to speak up. Okay. This is a very important point. You can write it in note. I already told you that if f is a state function, where we discussed about the state function and path function. If f is a state function, then delta f is 0 in cyclic process. I had given you a lot of example of a state function Do you remember when we have our first lecture of thermodynamics in the previous lecture basically? So I discussed about a state function as well as path function, intrinsic, extrinsic.
Yes, sir.
Yes, sir.
So I already told you that delta G is basically this G gives free energy, or you can say enthalpy or internal energy or temperature. These all are basically this entropy. These all are a state function. I wrote it. Do you remember?
Yes,
Yes, sir.
sir.
These all are state functions. So change in these points like delta G, delta U, delta H, delta S. What I wrote here is if F is a state function, these all are a state function, then the value of delta F in cyclic process, wherever a question is asked about this and asked the change in cyclic process, it will be zero always. It will be zero because the final because it doesn't depend upon path. It will depend upon initial and final state. And if initial and final state will be same, what will be the change? The change will be zero, like displacement.
Yes,
You
sir.
know what is
Yes, sir.
displacement? If if you are going out from home and roaming here and there and back to home, what will be your displacement? Displacement will be zero now.
Yes, sir.
Yes, sir.
Just like that, the change in a state function, the example for a state function is gives free energy, enthalpy, internal energy, entropy. It's all a state function. And in cyclic process, basically cyclic process says that uh, a process in which start from same point and end on the same point. That means initial and final are same, and if we will go for change and initial and final states are same, that means the value will be zero. Simple. Write it. A lot of questions had been asked on this. It's important.
Done, sir.
Done.
Very good. Now we will come to the main process, which is very important for this chapter and next two chapters, chemical equilibrium and ionic equilibrium, which is a reversible process. Reversible and irreversible process. Reversible and irreversible process. Now, going for a reversible process. You can see everyone done with this topic.
Yes, sir.
Very good. Ifra, Fawaz,
Yes, sir.
Yes.
see, we have a container in which piston is here and gaseous particles. Here is gaseous particles present. Now see, here is the piston. This is piston. Okay. And you know that P external will be, that means you are applying pressure on that. Now see, and here P P internal, that means pressure of gas, right? Everyone,
Yes,
Yes,
sir.
sir.
pressure inside container will be pressure of gas, and pressure outside the container, if it is not moving, then pressure, atmospheric pressure, and if it is moving downward, then that means you are applying pressure on that, and if it is moving upward, that means pressure is applied by gas on container on piston. Is that clear, everyone?
Yes, sir.
Yes, sir.
Fawaz?
Yes, sir.
Now see, here is a lot of sand particles. Fawaz, have you played with it?
Yes, sir.
Okay. Now see, here is a lot of particles of sands, and what you do, you just pick one sand particles and just go and kept it here. Keep it here. Will it be disturbed or not with one particle of sand? Will it affect it or not?
No, sir.
No, sir.
There will be no effect. Basically, reversible process is very slow. If you are going to pick another particle of repeat it for 50 times, will it be there any effect? Yes or no? 50 sand particles, I'm talking about 50 sand particles. Ifra, will it affect it or not? If it is no, in equilibrium, you can say that the pressure from outside is equal to pressure from the inside, that is equilibrium, that is it is stopped, it is in equilibrium basically. And if you are picking one sand particles and drop it there, then again, and if you did it for 50 times, then will it move or not?
No,
No,
sir.
sir. It will.
There will be no movement. Basically, reversible process is that process that it is very slow. The changes you will not that is you will the change will which cannot be considered. Is that clear?
Yes, sir.
It's very slow, it's very slow. So basically, if you are going for the 50th particle, 51st particles, 52nd particle, it won't affect it. And here P external will be P internal. Will it be or not, Krishna?
Yes, sir.
So it is very slow process, very slowly. So the process which is very slowly, that process is a reversible process. I'm going to write a good definition of it. The process in which the changes are so slow that it won't affect anything. That means P internal is equal to P external. That means P internal is equal to P external, which changes occurs very slowly, or here a term is used, infinitesimally. Have you heard of it? Infinitesimally. Krishna?
Yes, sir.
Okay. By series of series of equilibrium, basically you can say it, because it won't affect. If you will go and pick one particle of sand and drop it here, that will maintain its equilibrium. Another will go for second, it will maintain its equilibrium. Is that clear?
Yes, sir.
Yes, sir.
Of equilibrium is called a reversible process. Please write. And if you have any doubt about this, Fawaz, Krishna, and Ifra, ask me. Ask me.
Done, sir.
Done.
Everyone done?
Yes, sir.
Very good. So going for the next point of the same topic. Next point you can write. In this process, P external equals to P internal at every stage. In this process, P external equals to P internal at every stage. At every stage. Cause, this is very important, cause changes occur very slowly. Changes occurs very slowly. And you can also write the second point. The driving force which causes change. Driving force means change. The driving force is the force which causes change. You can write the driving force. Here we can write which causes change. In this process is negligible. Is negligible. So we can write here equation P external is equal to basically P internal plus minus dP. This dP is driving force. This dP is driving force, and in reversible process, dP that is equal to almost, we can consider it 0. So in reversible process, P external is equal to P internal, or P internal is equal to P external. If you are done with this, let me know.
Done, sir.
Done, sir.
Awaz?
Sir, 1 minute, 1 minute.
Okay. Okay. Sorry. Awaz done, or I need to pull it upward?
सर थोड़ा रुकिए.
Okay, okay.
Done, sir.
This reversible process is in infinite step, so I'm going to write this. This process is completed in infinite step. Infinite step. Therefore, it is not a real concept. It is not real concept. It is hypothetical concept. Is that clear, everyone?
Yes, sir.
Yes, sir.
So write it, and we will go to the next process, which is irreversible done, we will go for irreversible process.
Done, sir.
Okay. Fawaz,
Done, sir.
Done.
so come to the next, which is irreversible process. Irreversible process. Same same container I am going to take. Here is a container, and you can see there is a piston, and in which gases are present in the container, and here is the piston. Okay, and this is P external. You can see now here that a lot of sand particles are here, and if you are going to take 1 kg or more than 1 kg and you just keep it here, then will there be any change or not? Going with lots of sand particles, you can say 5 kg, 10 kg, 50 kg, and whatever, will there be change, sudden change or not? Ifra, Krishna,
Yes,
Sudden.
sir.
Sir.
Yes, sir. It will
will
be.
be sudden change. That will be that cannot be neglected, because in the previous process the process was so slow that we neglected it, but here the changes are so fast that we can see, we can feel the change, but in the previous process we cannot feel the change, because we just pick up one sand particle and put it there, another and another, and it was so slow and in infinite step that it can be neglected in the previous process, but here the changes are so large and so sudden that you can feel it and you can see it. Exactly, right?
Yes, sir.
So this type of process is irreversible. This type of process is irreversible. Going to write some points, write with me. The process which is carried out in finite step. It's not infinite, it's infinite. That means countable step is called irreversible process. It is real process. A very important chapter it is. It is fast process. That was slow, very slow. It is fast process. Another point we can write, in this process, driving force is large. Driving force is large. That means P external equals to P internal plus minus dP. That is, dP means change in pressure, and it is very large, that we won't neglect it. Write it.
Done, sir.
Done, everyone?
Yes, sir. Done.
Now see, Fawaz?
Sir, done.
Okay. And here you cannot neglect dp equals to 0. You cannot write because driving force is large. That's why dp is not equals to 0. And here is another important point, which is in this process, in the previous process, p external was equal to p internal. In this process, p external is not equals to p internal because dp is not equals to 0, because dp is not equals to 0. And here is another important points which I was talking about. Equilibrium exists. Equilibrium in the previous process, you will see that p external is equal to p internal at every stages. That means in the previous process, that is reversible process, right? That is reversible process now.
Yes,
Yes, sir.
sir.
In reversible process, it maintains its equilibrium at every stage. It maintains its equilibrium at every steps. But in irreversible process, the change or the driving force is so fast that it maintains its equilibrium position at only starting and final point. In between them there will be no equilibrium. Is that clear? Just see, here is the
Yes,
piston.
sir.
Try to understand, Krishna. Here is the piston. It is just stopped here. Now gas particles are here, and you are now going to put 5 or 50 kg of sands, and the piston will be moved to here. Just suppose move to here. That means before putting this 50 kg weight, it is in equilibrium, right,
Yes, sir.
Krishna and Fawaz? And after putting, when it will be stopped here, that means it is in equilibrium here at final position.
Yes, sir.
So I just want to say is that in irreversible process, there will be equilibrium, but the equilibrium will be at only initial and final stage, not in between initial and final stage, because it will be moving downward according to the situation, according to this situation. Is that clear,
Yes, sir.
everyone? Fawaz?
Yes, sir.
Equilibrium exists only at initial and final stage. Final stage. In irreversible process, external pressure is constant. Whenever there is a term in numerical value that says external pressure is constant, that means it is irreversible process. Very important point for numerical point of view.
Done, sir.
Done, sir.
That's
Very good. Now, if there is any doubt regarding this process, let me know. Sorry. Okay. Right to topic. Work done in thermodynamics. Work done in thermodynamics. Have you ever read about it?
No, sir.
So there are two types of work basically. Here it is, electrical work, and here PV work. PV work. We need to study about PV work, not electrical work. You will study about electrical work in class 12 physics. Now you will see a point. I'm going to write with me. If work is done against compression or expansion of gas is called PV work. Basically, you can see the container I had drawn previously. That is PV. That is compression. It will be expansion or compression. If there will be more pressure, wait. If this is the container and this is the piston, if there will be pressure from outside, it will be compressed, and if
It
will
is not visible.
okay, sorry. Thank you for telling me. Everyone, Krishna, am I audible to you?
Yes, sir.
Now see, here I had drawn a graph. This is a piston, this is the piston, and if you apply external pressure, will it be compressed or expand? It will be compressed.
Compressed.
Here what it says, work is done against compression or expansion of a gas is called PV work, and we will discuss about PV work now, how it will affect, and we will derive a formula. Okay, just write it. And let me know if you're done with this.
Done, sir.
Done.
Done, sir.
Now see, here you can see I'm going to write, draw that again. You can see here is the piston. Okay, now the initial volume of this container is Vi. I am going to write, and if you are going to apply P external, that is greater than P internal, will it be compressed or not? If
Sir,
you are
it will compress.
applying greater pressure than internal, Krishna, will it be compressed?
Yes, sir. Compressed.
It will be compressed. Just suppose it will be compressed, and it will be like it will be compressed and it will come to this point. It will come to this point, and the final volume is V final. Is that clear, everyone?
Yes, sir.
Now we need to find work done. You know that dW equals to F dot dx. Have you studied about it or not? Work done
Yes.
in
Yes, sir.
Krishna, in physics,
Yes, sir.
W equals to F dot S, force into displacement, Fawaz, and if we are going to
Yes, sir.
for dW, it will be F dot ds. Now you can see dW equals to, and you also have studied that pressure equals to force upon area. So force is equal to pressure into area, right?
Yes, sir.
So I'm going to replace this force with pressure into area, and this dx will be here like the previous. Now again you can see dw equals to, this is area. Area into length gives volume. Area into length gives volume, and area into change in length gives change in volume. So I can write dw is equal to p dv. I can write or not?
Yes, sir.
If there is any doubt, ask me right now. Okay, now I'm going to integrate it both side, p dv, and there will be a final formula which is w equals to p external into dv. And you know that for irreversible process, the p external is constant, right? And by convention, in the formula of work done, there will be negative marking. Okay, everyone, this
Yes,
negative
sir.
marking is very important. You will come to know in this coming 15 minutes. This is why this is important. In the formula, we will have formula like p external into delta v, you can also write, and you will see a lot of different formulas in the same way. Like you can also see like this, p external v1 to v2, and it will be dv like this also. What does this represent? v1 and v2, this is upper limit, and this v2 is upper limit and v1 is lower limit. Is that clear?
Yes, sir.
Yes.
Just write it.
Done, sir.
Everyone done?
Done, sir.
Sir, just a second, sir.
Okay.
Done, sir.
Very good. Now I have given you a formula. Now we will go for sign convention. Why minus is important and what does it says? Basically, this is very important. You can see it is sign convention of work. Wait, sign convention of work. Basically, there is a difference in physics, thermodynamics and thermodynamics of physics and thermodynamics of chemistry. Both chapters you same chapters you will study in physics, and you are studying in chemistry. Okay.
Okay.
Yes, sir.
Now see, that depends upon the reference only. That is the difference. Only in sign, only in the sign positive or negative. In physics, I'm going to tell you what it took as a reference, and in chemistry, what we took as a reference. Here, if you will talk about physics, the reference is gas. We talked with the reference of gas, we calculate work done with the reference of gas. Expansion of gas, that is positive. Expansion of gas, that is positive. Work is positive if gas expand. Is that okay?
Yes, sir.
Yes, sir.
And compression of gas, that is negative in physics, but it will be opposite in chemistry. This is for compression and this is for expansion. Now what about chemistry? In this, in chemistry, a reference point is external agent. Reference point is external agent, like external pressure, or you can apply pressure, is like that. External agent is the reference in chemistry. What does it says? Work done on the system, on the work done on the system. If you will do work on the system, will it expand or compressed? Let me know. If you will do work on the system,
Sir,
will it
compress.
expand?
Compress, sir.
It will be compressed. Fawaz,
Yes, sir.
then compression will take place. And whenever you work done on the system, work done will be positive. Now you can see the difference: negative, positive, positive, negative. And if the work done by the system, if work done by the system, if work done by the system, then expansion will take place and work done will be negative. Don't write it, first understand it, then write it. Now see, what I want to say is that if there is container with a piston, you can see how it will compressed. If you will work done on the system, it will be compressed. And if work done by if work done on the system, then work done will be positive. And whenever work will be done on the system, it compression will take place, right?
Yes, sir.
And if there is gases inside the system, work done by the system, that means gas will work on the piston and it will expand, right?
Yes, sir.
Fawaz,
Yes, sir.
are you getting it or not?
Sir, a
Fawaz,
little bit.
little bit. Just see, what I want to say is that which factor will be responsible for the compression of the gas, external or internal? Compression, you know, the volume will be decreased, right?
Yes, sir. Yes.
So which factor will be responsible, external or internal, for compression?
Sir, external.
External. And external, that means you will apply force or pressure on this. External means the from outside. So whenever we do work on the system, on this system we do work, it compression will take place and work done will be positive, right?
Yes, sir.
And how expansion will take place? If work done work done by the system, if work will be done by the system, this will expand, right? So you can remember it in two ways. If work done by the system, then it will be negative. If work done on the system, it will be positive, right? Ifra and Krishna and
So,
Fawaz.
yes, sir.
Yes,
Yes,
sir.
sir.
So after this, you will write in expansion, basically volume will increase and delta V is positive. And you can see W is equal to minus P external into dV. That was the formula in the previous slide. And W is equal to, this is positive, but in negative, it will be negative or positive. You can see for the expansion, that means delta V positive or not for us.
Yes, sir.
Delta means change. Delta V means volume, change in volume. That is final volume minus initial volume. If expansion will take place, that means final volume will be increased. That's why delta V is positive. And you can see again for the expansion, work done will become in negative. Everyone okay with this?
Yes, sir.
Yes, sir.
Okay.
Right. Right.
Done, sir.
Done, sir.
Done, sir.
Very good, everyone. Now I'm going to give some questions. Work done in irreversible process. It's not question. Let me case one. Right, case one. Work done in irreversible process. Just see. I'm going to derive formula. Then we will practice question. Work done in irreversible process. You know, we have a formula for, just don't write it and understand it, then write it. We have a formula I already wrote, negative P external from V1 to V2, and it will be dV. And I have already told you that if they in irreversible process, P external will be constant.
Yes,
Ifra,
sir.
Krishna
Yes,
and
sir.
Fawaz, P
Yes, sir.
external will be constant. You can see minus P external will be outside of this integration sign, and here it will be dV V1 to V2. For integration of dV is Fawaz, integration of dV. Ifra,
Sir, V.
what you just said? Integration
Sir,
of
V.
V. Very good. V, and here it will be lower limit minus so lower limit and upper limit. And when we will solve it, it will be upper limit minus lower limit. This is final volume, this is initial volume, and you can also write final minus initial, that will be delta V, or you can write minus P external dV. This formula is for irreversible process. This formula is for irreversible process, or I can write WIRR equals to minus P external into V2 minus V1. These all are irreversible process, work done formula for work done by irreversible process. Yeah, write it now. Done?
Done, sir.
Yes, sir. Done.
Okay,
Done,
going
sir.
to the question. Very good for us. Okay, question here is 4 mole of an ideal gas expands from 5 liter to 12 liter against constant external pressure of 180 calculate work done. If you're done, am I audible?
Yes, sir.
Yes, sir. You are.
Yes.
Am I visible?
No, sir.
No, sir.
Okay, I will be. And there is- Okay. If you are done with this question, let me know. Done, everyone? Ifra?
Sir, 7 liter per ATM minus.
7 liter per ATM.
Yes, sir. Minus.
Very good. Anyone else?
Yes, sir. -7.
Not -7 only, it's liter ATM. You can see here it is external, constant external pressure. That means irreversible process, right? Fawaz?
Yes, sir.
And we have a formula for work done, that is minus P external dV minus, what is the P external? 1 atm. What is the volume V2? It is expanded to 12 liter minus 5. That will be equal to -1 into -7. That will be equal to -7 liter atm. If I will ask in joule, what will be? Sorry, wait a minute. Convert it into joule. Can you do it, Krishna? Krishna?
So I might need your help, sir.
Okay, no problem. Ifra, 1 liter ATM equals to
100.
101.3 joule. So in joule, it will be 7 into 101.3, right? This is very important. 1 liter ATM equals to 101.3 joule. Okay. Fawaz.
Okay, sir.
Okay, thank you. Done with this?
Yes, sir.
Yes, sir.
Fawaz.
Sir, 1 minute.
Okay.
Okay, done, sir.
Okay. Going for the next question. Against constant external pressure. This is the question. Calculate the work done in joule. In joule.
Sir, 4 into 101.3 joule.
What's your answer, Krishna and Fawaz? Will it be negative in and or positive?
Sir, it
Certainly
will be
positive.
positive.
Will be positive.
So because work is done by the system. Sorry, work is done on the
It is
system.
done by the system. By the system. Whenever work is
On-
done by the system, if there will be sentence like work is done by the system, it will be negative.
Yes,
Work done
it
on
is
the
done
system,
on
it
the
will
system
be positive.
positive.
Fawaz, have you got your answer?
Nice, nice.
This is very easy for us. You can see against constant external pressure. I forgot to write constant external pressure. That means irreversible process. And wherever irreversible process, there will be formula P external into dV, change in volume. P external is 1. You can see here 1 atm, and dV, that is final volume minus initial volume. Final volume is 6 liter, 10 to 6 liter, 6 minus 10, and it will be minus 1 into minus 4. That will be equal to 4 liter ATM. Was right?
Yes, sir. Yes.
And in joule, it will be 4 into 101.3 joule. Okay, Fawaz,
Okay, okay.
take your time and write it. I'm going to write another question. This is a very good question, Ifra, Fawaz, and Krishna.
Sir, is it 12 liter to 6 liter?
It's 12, it's 12 ATM. If you're done,
Sir, I'm just. It's a 1 minute.
Sir, can you help solving it, sir?
okay, no problem. If you're done, I was waiting for your answer. No problem. Just see.
Sir, will it be done in this way that we will find volume at 12 atm and at 6 atm from ideal gas equation?
Exactly.
And then
For Krishna and Fawaz, it's constant external pressure. That means work done by irreversible process, and it will be P external into dV, right? So we are going to apply the same formula, work done by irreversible process, that is P external. What is the P external? You can see P external of 1 atm, that is 1 atm, and we have a formula V2 minus V1. We can easily find out V2 from ideal gas equation. From ideal gas equation, you can see PV equals to nRT. So V will be equal to nRT upon P, right? So we can have minus 1 into V2. What is V2? V2 is nRT upon P, and what will be its pressure? This 6 atm, because it is against V2 for P2, then it will be nRT upon 6 minus nRT upon this 12 V1, and you can solve it by taking common
sir, it's the
nRT upon into 1 by 6 minus 1 by 12. Krishna, are you getting it? And
Yes, sir.
Fawaz? And you can easily solve it nRT into after solving this, you can take 12 as LCM, 2 minus 1. It will be nRT number of moles. How much number of moles is here? 4. And what will be the value of R? What will be the value of R? You can take
sir,
it
0.082.
no 8.314, you can take it, so it will be joule, and temperature is 27 degrees centigrade, so it will be in Kelvin, and the value will be 1 by 12. Now you will multiply and the value will be in joule, directly in joule. Done, everyone? First, recognize what is it, whether it is reversible process or irreversible process. There is a very common point against constant pressure, constant external pressure is given, that is irreversible process.
Done, sir.
Fawaz?
Done, sir.
Okay. So I have given you the formula for irreversible process. Case 2. Wait. Case 2. Work done in a reversible process. What is it? A reversible process. Work done in reversible process, we know that P external is equal to P internal, right? In reversible process, the pressure is equal in internally and externally, right?
Yes, sir.
So P external is equal to P internal. This is the condition for reversible, and work done equals to minus P external into dV. We know that, and we can also write in place of P external as P internal because both are equal. Okay, and P internal is for gas, right or not?
Yes, sir.
Because you know that there is a piston, there is a system, and here is a lot of gases, and here is the piston, and here P external, and here it is P internal. That is P external is equal to P internal, and P internal is for gas, so we can write PV is equal to nRT for gas.
Yes, sir.
So what we are doing going to do, minus, in place of P internal I am going to write uh, nRT upon V. Is it okay with you? At place of, wait a minute, in the place of P I am going to write nRT upon V, and dV was there, Krishna.
Yes, sir.
For P we can write nRT upon V. Now number of moles R and temperature are constant, so I can take it outside. So, and it will be minus nRT into 1 by V dV. Do you know what is the integration of 1x? Do you know what is the integration?
1x.
It is ln x. It is ln x. So after integrating it, and we can give limit from v1 to v2. So it will be nRT, and it will be ln v. The integration of 1 by v is ln v from v1 to v2. We can easily write. Okay, just see. So we can also write nRT upper limit minus lower limit. So it will be ln v2 minus ln v1. And I already had some logarithmic formulas. Log a minus log b can be written as log a upon b. Is that okay? And log a plus b, log b can be written as, it is logarithmic formula, log a into b. And log a raised to the power n can be written as n log a. Is that clear, everyone?
Yes, sir.
Yes,
So
sir.
here it is the formula of W, work done. W is equal to nRT, and here you can see log a minus log b. So I can write ln v2 upon v1. Fawaz,
Yes, sir.
and you can change ln into log. That will be equal to, whenever we need to change in log from ln, we write, we multiply it by, wait, that was good, we multiply it by 2.303. 2.303. So we can easily write W is equal to 2.303 nRT log of V2 upon V1. This is our final formula. Okay, everyone. If there
Yes,
is
sir.
any mathematical um term that you are not understanding, let me know. Fawaz. Okay, sliding to upward. Right.
Done, sir.
Done, everyone?
Yes, sir.
Done, sir.
Okay. Right. How many chapters are coming in the final paper?
So I think so 7.
7. Is it states of matter is included? I think
Yes, sir, it's included.
states of matter, thermodynamics, equilibrium, hydrocarbon, right?
Yes, sir.
So, 3, 4 chapter, S block, P block, 6
Yes,
chapter.
sir.
And then which chapter is left? Chemistry in everyday life.
So the other chapter is aromatic hydrocarbon. Hydrogen.
It is hydrocarbon. I have already counted it.
Okay, sir.
I'm just writing it. States of matter that we have completed. And
So equilibrium.
that is also I have counted it. Equilibrium and hydrocarbon and S block and P block. And which chapter? 3 chapters from the first book and these 3 from the second book. Hydrogen I don't think it's okay.
No, sir, it's not there for the second one.
Is it done, everyone?
Yes, sir.
Okay.
Yes, sir.
Now see, we have a formula. If you have remembered Boyle's law, you know that from Boyle's law we got a formula: P1 V1 is equal to P2 V2, right?
Yes, sir.
Yes, sir.
So we if you are going for V2 upon V1, will it be equal to P1 by P2? Yes or no?
Yes, sir. It
Yes,
would
sir.
be.
It will be equal to, that means work done in terms of pressure minus work done in terms of pressure, that is equal to minus 2.303 nRT log of P1 upon P2. In place of V2 upon V1, can I write P1 upon P2, yes or no?
Yes, sir.
So just write the another formula with the help of Boyle's law. So we have completed work done. In the next class we will have internal energy, then enthalpy, if you are done with this, let me know.
Yes, sir. Done.
Done, sir.
Very good, very good. Whenever you are done, please let me know. I just wait for you people. Another questions. 2 liter of an ideal gas expands isothermally into vacuum up to 10 liter, find the work done. Find the work done. Done.
So please, can you tell how to solve this?
This is very easy. This is what it is talking about is vacuum, and in vacuum P external equals to 0. Wait a minute. In vacuum, P external is equal to 0, and if P external equals to 0, what will be work done?
So
Krishna?
0.
So dV, that is 10 minus 2, whatever you do, but P external is 0. Whatever is the quantity, it will be 0 or not, Krishna?
Yes, sir. It's 0.
So whenever there will be vacuum or free expansion, that is also known as whenever there is vacuum or free expansion, the work done will be 0 because P external is 0. Is that clear, Fawaz?
Yes, sir.
What happened to you? You don't speak much now.
नहीं नहीं.
Is everything all right, Fawaz?
हाँ सर, सब सब बढ़िया.
So I'm going to write definition of free expansion. The expansion of gas in vacuum where P external equals to 0 is called free expansion. And you can write another point. In free expansion, work done is 0. In reversible as well as irreversible process. Irreversible process.
Done, sir.
Thank you. Everyone? Krishna?
Yes, sir.
Fawaz?
सर लास्ट लाइन बाकी थी.
Okay. This line.
हाँ yes sir.
And you can write from note is that free expansion, or another term uses vacuum or evacuated. In these three terms, That means P external equals to 0. Whatever from these terms will be used, and that means work done will be equal to 0. Okay, everyone. So everyone has NCRT, right?
Yes, sir.
Yes, sir.
Very good, very good. From exercise, I'm going to give you questions. Are you done, Fawaz?
Yes, sir.
Okay, question number 1, question number 2. No more question, come on. And problem 6.2, 6.3, 6.4. Only these questions I'm going to discuss first in the next lecture, and then we will start. Okay, we'll do
Okay,
practice
sir.
questions on a reversible process. Okay.
Okay,
Is
sir.
there any doubt today on this
No,
lecture? Okay. Awaz?
Sir.
Okay.
Okay, thank you, sir.
Okay. Thank you, everyone.
Thank you, sir.
Thank you.